Okay, so we have one last example, and that's 81.4. So let's do 81.4. It's talking about two cables that are attached to a vertical tower. So here's your vertical tower. You have a point. You have two cables attached to that tower. And it says that these are 50 feet apart. And we know that this is 15 degrees. And we know that the top cable is 150 feet, and we need to find the length L of the shorter wire. So we do not know this angle B, and we do not know this angle up here, which they have not named. But we will use, we'll notice there are no pairs that we can use. Actually, there is a pair. We can use 15 and 50, so we can use the law of sines in this case to figure this out. So since there is a pair, we can say 50 over the sine of 15 degrees equals, let's see, what am I trying to do here? I want to find this length. So, but I don't have either number here, so that's not going to help me with two unknowns. I do have this number here, so I can use that. So 150 to the sine of B. Okay, so 50 sine of B equals 150 sine of 15. Divide both sides by 50. So sine of B equals 150 sine of 15 divided by 50. 150 sine of 15, sorry, forget to show you what I'm doing, divided by 50. We get the sine of B is 0.77, and 0.78. Okay, and take the inverse sine of that answer, and you get B equals 50.94. So B is 50.94. When I come up here, that doesn't quite make sense because a 50-degree angle is going to be a lot smaller. So I know it's got to be 180 minus 50.94. So 180 minus 50.94. That's going to be 129.06. So that makes a lot more sense that this is 129.06. So now we can use that to figure out what our third angle is. So 129.06 plus 15 plus that third angle, I'll just call it x, equals 180. So 180 minus 129.06 minus 15, 35.94 would be that last angle. So let's see, 35.94. So you can use the law of sines again, or you can use the law of cosines here. In the book they use the law of sines. The reason why you use the law of sines here is when you're doing angles, there's ambiguity, but when you're doing side lengths, there's no ambiguity. If we use it to find the length of a side and it tells us that's the length of the side, that has to be the length of the side. You can't add it or subtract 180 degrees to the side because it's not a length, or because it's not an angle. So let's just do that. We'll use law of sines one more time. And so we will do L is to the sine of 35.94 as 50 is to the sine of 15. Okay, so L sine of 15 equals 50 sine 35.94. Divide by sine of 15. So L equals, and now just use your calculator. We will do 50 sine of 35.94 divided by sine of 15. And we get L is 113.39. And that is in feet. So 113.39 feet is the length of that second cable. So kind of a lot of work to get the answer, but hopefully that made sense.